Okay, so we're looking at how we actually solve those inequalities. I'm on the back of our notes. We're going to look at example number 2. So if I pretend this was an equal sign, what would I do to get y by itself? I take away the 25. I'd subtract 25. So I'm going to go ahead and do that. And so my result is y is less than negative 13. Is my variable all by itself on one side of that inequality? Yes? Then I'm done with the solving, and now I need to graph the solution. So I'm going to find negative 13, and the symbol says less than. So less than means I'm going to color on this side to the left of it. And because it's strictly less than, it excludes the negative 13, and I do not color in that circle. Okay? I want to look at number 3. When you're ready, I want to look at example number 3. Pretending it's an equal sign, how do I get n by itself?
Or add.
Because that negative sign, right? But what's the symbol between the negative 8 and the n? Yeah, there isn't one, so it tells you it's multiply. How do you undo the multiply? Divide. So while it kind of looks like you might add, you're actually dividing. Now remember, we made this note that whenever we multiply or divide through by a negative, this symbol gets flipped. So the moment you multiply or divide by a negative, that should be the first thing you do, is flip that inequality. These cancel, leaving me with n, and on this side I have 9. Someone with a calculator or better at multiplication, make sure that I did that right.
Nope. Not you right.
I'm right, okay, good. All right, we're going to find 9. And this says less than, so I'm going to color to the left.
The opposite way, maybe?
What do you mean the opposite?
Like if it shows that it's going this way, do you go that way?
No, we're going to color the direction that it gave us. The flip already happened right here. Originally it was greater than, now it's less than. Now looking at this symbol, do you see the or equal to bar?
Yeah.
That means it includes, so you're going to color in that circle that you put at 9. Okay? Process remains the same, even if you have more than one step happening. Does anyone want to see any of these other examples, 4 through 7, before we move on?
No.
Okay, so the fractions are okay?
Yes. Yes.
I heard a no. Okay. So I've got someone wanting to see the fractions. If you're feeling comfortable with this and you want to go back to your daily work, you're more than welcome to. So for the no that I heard, it was one of these. You want to see them both or just one? Just one. Which one? 6 or 7? 7. All right. Looking at 7, I need to get n by itself. The subtraction is outside of the fraction, so I'm going to get rid of that first. I'm going to add 17 to both sides. Now when I'm looking at this, I have a number with a decimal. This whole number has a decimal after it, so I need to add the stuff to the left of the decimal and the stuff to the right of the decimal. So this is 3 plus 17, 20.5. I have to get rid of the fraction. Fraction means divide. And to undo division, I need to
Multiply.
Am I multiplying by a negative number?
No.
No, then this symbol stays exactly the way it is. There's no flipping because it's a positive number.
Wait, Miss, if you divide, don't you flip it?
Only if it's negative.
Only if it's negative. Oh.
Only if it's negative. Multiplication, division flips it only if the number you're dividing or multiplying by is negative. And then this is, I think it's 41. Let's go ahead and draw our solution. Put the 0 and then put the 41. Those are really the only numbers that are important here. I'm going to put a circle around the bar for 41. My thing says greater than, so I'm going to color onto this side, the greater than side. And then I have the equal to bar, so I'm gonna go ahead and color in the circle I drew around 41. And I'm done. Feel better?
Yep.
All right.